All right, let's talk about Project Helix. This is a really cool hands-on lab series that's all about helping you build a serious, career-defining portfolio project. And the best part, you can do it in just 30 days. So if you're an engineer or you're in DevOps or architecture, you've probably felt this before, right? How do you build a project that shows you can do more than just follow a tutorial? Something that proves you can actually solve the messy, complex problems you see on the job. Well, that is exactly what we're going to dig into today. Here's the game plan. First, we'll break down what Project Helix is at its core. Then, we'll look at the unique 30-day structure it follows. After that, we'll cover the foundational self-hosted lab and then jump into the cloud editions for AWS, Azure, and GCP. And finally, we'll bring it all home and talk about why this thing becomes such a powerful piece for your portfolio and your next interview. So, let's get right to it. What are you actually building when you decide to take on a Project Helix lab? At its heart, Project Helix is a data migration simulator. Think of it as a 30-day challenge where you get to roll up your sleeves and get your hands dirty with a super common, super realistic engineering task: moving and cleaning up a bunch of data. The whole scenario is a classic. I mean, you've probably seen this in the wild. On one side, you've got the source, a mess of old, disorganized data, maybe from flat files or some ancient database. And on the other side, you've got the target, a clean, modern, properly structured database. Your job? Build the automated pipeline that gets the data from that messy state to the clean one. And listen, this is not just a simple data dump. We're talking real data cleanup. You'll be writing Python code to do things like split a single name field, last name, first name, into 2 separate columns. You'll standardize all kinds of inconsistent date formats. And here's a big one. You'll take a single field that has a bunch of comma-separated values and explode it out into properly normalized records in a totally separate table. It's all about ensuring data integrity from start to finish, which is an absolutely critical skill for any data-heavy role. So, how in the world does this all get done in 30 days? Well, Project Helix isn't just some random list of tasks. It's built on this really smart, repeatable weekly blueprint. It gives a nice, predictable rhythm to all your work. Every single lab, it doesn't matter if it's the local one or one in the cloud, follows this exact same 4-week cycle. Week 1 is all about getting your foundations right, setting up your environment, and using infrastructure as code to provision your databases. Week 2 is the fun part. You build the core Python ETL pipeline. ETL stands for extract, transform, and load. It's the real heart of the migration. Then, in week 3, you automate the whole thing. And week 4 is all about proving it works, documenting it, and getting ready to talk about it like a pro in an interview. You know, that week 3 Nuke and Pave exercise? It's a game changer. You literally destroy everything you've just built. And then you prove you can bring it all back to life with a single script. This is so much more than a cool party trick. It proves your entire pipeline is 100% reproducible. That's a skill that hiring managers go nuts for, especially for senior roles. Okay, before we even think about jumping into the cloud, let's talk about the starting point for a lot of people, the self-hosted core lab. This is the foundation for the entire series, and it's totally cloud agnostic. In this lab, everything, and I mean everything, runs right on your own computer. You'll use Terraform to manage Docker containers, spinning up 2 separate MySQL databases for your legacy and modern data. The whole ETL engine is built in Python using popular libraries like Pandas and SQL Alchemy. You'll even get to use Ansible to automate setting up your own workstation. This lab really drills in the fundamental patterns of IAC and ETL without you having to worry about any cloud bills or complexity. All right. So, once you've nailed down those core concepts locally, it is time to take your skills to the big leagues, the cloud. Project Helix has these dedicated labs for AWS, Azure, and GCP, where you solve the exact same problem, but using powerful cloud-native services. And this slide really nails that multi-cloud story I was talking about. You can see right here how the same core challenge gets solved a little differently on each platform. That local CSV file? Well, in AWS, it becomes an S3 object. In GCP, it's a cloud storage object. The MySQL database in a Docker container? That becomes Amazon RDS, or Azure Database for MySQL, or Google's Cloud SQL. See? The core logic is the same, but the tools change to fit the environment. Let's kick things off with the AWS lab. Here, the focus is all about using core AWS services like S3 for your file storage, RDS for your managed database, and VPC for all your networking. When you finish this lab, you're not just saying you've used AWS. you're proving you get the fundamentals. You will learn to provision an entire virtual network, an S3 bucket, and an RDS database, all with Terraform. You'll get practice with IAM for security, and, this is super important, you'll learn how to do it all within the AWS free tier to keep your costs down. You end up with a full pipeline, all the way from a file in S3 to a clean schema in RDS. So that's the AWS approach. Now let's see how we tackle the exact same problem over in the Azure ecosystem. This lab uses Azure's managed database service and even brings Ansible back into the picture for a really slick automation story. The key player here is Azure Database for MySQL, specifically their flexible server option. You'll use Terraform to deploy it inside a resource group, write your Python pipeline to connect to it, and even use Ansible on the Windows subsystem for Linux to automate your dev setup. You'll walk away from this one with a proven end-to-end pipeline built completely on the Azure platform. And finally, let's head over to the Google Cloud Platform Edition. This one is all about its core storage, database, and identity management services. In the GCP lab, you'll fire up Terraform to provision a network, a cloud storage bucket for your data, and a Cloud SQL instance for your database. One of the key skills you'll really sharpen here is managing GCP's IAM and service accounts to make sure everything has secure, lockdown access. You'll build the whole reproducible environment and prove you can wire together these core GCP services to solve a real-world data problem. Okay, so you've done all this work. What's the actual payoff? Why is committing 30 days to this so valuable for your career? Let's connect all the dots. The payoff is huge. Seriously, you end up with a complete, realistic pipeline that covers everything: infrastructure as code, ETL, data normalization, and verification. If you do more than one lab, you can walk into an interview and tell a fantastic multi-cloud story, explaining the pros and cons of solving the same problem on AWS, Azure, and GCP. And maybe most importantly, these labs are not simple hold-your-hand tutorials. They're designed to make you troubleshoot and do your own research, which, let's be honest, is what real engineering is all about. And that right there is the key. Project Helix is designed to make you a better engineer. It's about moving past just following a recipe and learning the real problem-solving and system-building skills that companies are desperate for. You learn the why behind the what. So I'll just leave you with this one question. Are you ready to invest 30 days to build a project that you can walk into any technical interview and explain with total, complete confidence, from the code all the way down to the infrastructure? Because that is exactly what Project Helix helps you build.